All right, in this review question, question 20, we're being asked to do a couple of things. We're being asked to identify the vertical asymptotes and the horizontal asymptotes of these equations, and we want to state the transformations, which I usually like to do first. And then finally, we're being asked to graph. So let's start with the transformations. In this equation, I have a +1 at the end. That's the k position. It's at the very end, which means that's going to move us up one spot. I also have a -1 inside the denominator with x. That's the h position. And a negative moves us to the right. So we're going to the right 1. Last but not least, I have a 4 in the numerator. That is a stretch. That's an a value. So that's going to stretch by 4. Those are all 3 of my transformations. Now I can find my vertical and horizontal asymptote. Remember, the vertical asymptote goes up and down. So it's going to be affected by side-to-side movement. I've moved to the right 1 spot, which means my vertical asymptote is going to end up at the x value. X cannot equal 1. It's moved to the right 1 space from 0. My horizontal asymptote goes side to side, so that's going to be affected by up and down movement. I've moved up 1 spot, which means the y value I can't get to is going to move up to the number 1. Now all we have to do is start graphing, so I'm going to start by graphing this horizontal asymptote. It was at 0. That's where it is in my parent function. It has been moved up 1 spot, which means my horizontal asymptote now runs here. And we should graph it with a dotted line. I've also moved my graph to the right 1 spot because of this transformation. That's my vertical asymptote has been moved to the right. So I'm going to go ahead and draw my vertical asymptote as a dotted line, 1 unit to the right. What you'll notice is the spot where they cross has moved away from the origin to the right 1 spot and up 1 spot, which is exactly what we said was going to happen in our transformations. Now I have to actually graph my function. To graph my function, all I have to do is use the pattern I'm used to move it away from my origin, the place where my asymptotes cross. Now the stretch by 4 means that instead of moving over 1 and up 1 like my original parent function, I should be moving over 1 and up 4. That's what my stretch is going to do. So over 1 and up 1, 2, 3, 4. That's the first point of my actual graph. Now if you're interested in using the second point, I can also move up 1 and over 4. That's also a point on this graph. And then we can connect these dots and move them close to the asymptotes without ever actually reaching. There we go. Now we'll do the same thing on the other side of my function. I can go to the left 1 and 1, 2, 3, 4 down. I can also go 1 down and 1, 2, 3, 4 over. Those are the other 2 points of my function. And they will try to get close to my asymptotes, but they will never reach. There we go. That's it. All you have to do is show me the over 1 and up 4 for one of these movements, over 1 and up 4. As long as you do that, over 1 and up 4, and you don't have to do this second over 1, up 1 and over 4. As long as you do one of them on the test, you will be fine. I do recommend doing both, though, because it's more exact. Anyway, let's go ahead and take a look at question 21. Very similar thing. We're going to start by talking about the transformations. So in this function, we have a big old -2 at the end. That's the k position. That means we're going down 2. We also have this -3 inside with x. Again, that's the h value, and the minus means we're going to the right. 3 spaces. We also have this 2 in the numerator, which means we are stretching by 2. If it's more helpful to draw the graph before labeling your asymptotes, that's fine. All you'll notice is that the point where my asymptotes intersect has gone down 2 spaces and to the right 3. They usually intersect at 0, 0, but they've moved down 2 and to the right 3. Now I can draw my vertical and horizontal asymptotes. The vertical asymptote has been moved to the right 3 spaces. The horizontal asymptote has been moved down 2 spaces. And we can see that they intersect at that point there in the center. So if it's helpful for you to do that first, then you can label your vertical asymptote using the graph that you've just drawn. The vertical asymptote is happening at x cannot equal 3. And the horizontal asymptote that's been shifted down, that one is happening at y cannot equal negative 2, because it got shifted down 2. Now all we have to do is draw the rest of our graph, and we're going to use these transformation here, the stretch, to show what that's going to do. The stretch is going to move us over 1 and up 2 instead of over 1 and up 1. So from the place where my graphs intersect, or where my asymptotes intersect, I will move over 1 and up 2. That is the first point on my graph. Again, if you want to also move up 1 and over 2, you can do that as well to get a more accurate representation. Our graph will try to get toward the asymptotes without ever actually reaching. Same thing on the other side. I will move to the left 1 and down 2 because of my stretch. I can also move down 1 and to the left 2 to get more accurate. We will try to get close to my asymptotes, but we will never reach in either direction. That's it. We have our graph. In the next video, we'll take a look at identifying and calculating asymptotes and zeros for our functions.